This is about total internal reflection in prism. So you must be knowing what is total internal reflection. When a ray of light passes out from a denser medium to a rarer medium, right, then it is called refraction. So when it passes, the amount of light gets reflected back in the same medium, and that is reflection. So majority of the light ray refract and some of it get reflected. Say out of 100, 90 can come out, 10 can be reflected back, right? And if you increase the angle of incidence, then the angle of refraction will also increase. And if you keep on further increasing the angle of incidence, you will find the entire ray of light get reflected only in the same medium, does not go out. So that is a scenario of total internal reflection. So let me explain this to you with an example here, and then we will have more about it. See, if there is a ray of light coming from somewhere inside the medium only, okay, say this is the source of light here somewhere, this is the source of light. So what happens when we have this particular angle of incidence? So you know what is angle of incidence here? It will get refracted, right? It will get refracted. So you can see the angle of, since it is coming out from the denser medium to a rarer medium, then it will refract away from the normal. Now if I further increase, this is the angle of incidence that we have. If I increase the angle of incidence, this also will increase. If I further increase, it will become parallel to the surface. So this angle is called critical angle. This angle of incidence is called critical angle. And when we further increase this, then it will no more go there and come back into the same medium. Okay, so actually the figure is not that proper, so let me just try it here. Angle of incidence should be equal here. Okay, so there will be angle of refraction, which is, reflection will be there as such. No light goes out of it. So this angle of incidence through which all the light have came back as a reflected ray inside the medium is called, this is called total internal reflection. Now this total internal reflection happens in prism also. Why prism? Because prism is also a denser medium. So when we have a source of light in a prism here somewhere, say for example, when we have a prism here and we have a source of light somewhere entering it, okay, then it will refract, and after that it can refract back also. So what do we have in the total reflection, total internal reflection through a prism? What are the scenarios that we have in it? So we have different cases in it. One of the cases that the total reflection, internal reflection happening through a prism which has an angle of 45 degree, 90 degree and 45 degree, or we can say is right angle isosceles prism, because when we have 45 two angles means their two sides are equal, and one of the bigger, okay, one of the side having a 90 degree angle there in it. Okay, so it's an isosceles trapezium, isosceles prism we can say. In this there are three cases here, sub cases we can say. That one will be it to deviate a ray of light through 90 degree. Second, to deviate a ray of light through 180 degree. And third, to deviate a light to erect an inverted image without producing deviation in its path. So we will go through all the three diagrams in it and three figures and see how does it work. First one, to deviate a ray of light through 90 degree. So see, this is a isosceles, right angle isosceles trapezium. What is the angle here? This is 90 degree. You can see that. Fine. and these are 45 45, so these two sides are equal. AB is equal to BC. This is why we call it as isosceles right angle prism here. Now how do we say, before we go on, we need to know what is the critical angle of say this medium, glass medium. So critical angle, remember I mentioned critical angle earlier. So critical angle is what? Is that angle, right, after which it will go through total internal reflection. Is that okay? So which means in this case I had given you, if this was the, okay, the ray of light is incident here and it becomes surface parallel to the surface. So this angle is called incidence, a critical angle. And if I further increase angle and then it goes what? Through total internal reflection. So that is, okay, it's not the critical angle, is more than critical angle because we are increasing the angle of incidence in that case. So the critical angle of this particular glass prism is, see here, critical angle is 42 degree. So which means that if you incident the light on this, which is more than 42 degree, right, then it will go through total internal reflection. So see, what are we doing in this? This is a right angle prism here. So we allow a light to, okay, get into this, right, at an angle of incidence 0 degree, which is perpendicular to the surface here. When the ray of light is passing or entering into the prism at 90 degree, I mean angle of incidence is 0, angle of incidence is 0 degree, then it will go on deviating. Now since this is parallel to the base, which is 90 here, these two lines are parallel, so this will be also 90. If this is 90, then what is this angle here? Remember, this is 45, this is 90, this will be 45 degree, right? And if this is 45 degree, then we know that this is a normal here. So if this is 45 and this entire thing is 90, so this will also be 45 degree. Getting my point here? Once again, see here, these two lines are parallel. This is 90, so this also will be 90 because of parallel. Corresponding angles are equal. In the triangle QAQ, say let it be M, AQM. Then we know the sum of all the three angles should be equal to 180 degree. This is 45, this is 90. How much will this be? This angle will be 45 degree. If this is 45, we know we have drawn a normal here. Normal is always at 90 degree to the surface. So if this is 45, the rest of it also will be 45. Now, so is this angle of incident inside this, is it more than the critical angle? Yes, it is more than critical angle. So it will go through total internal reflection. So whatever angle it makes, it will reflect with the same angle. And what is angle? This angle should be also 45 degree. I hope this is clear. Now, this is 45. Now it comes out, right? It will come out. So this is 45, right? And the entire thing is 90 here. Will it not be parallel to this side? You can see total is 90. Total is 90 and this is also 90. This is also 90, right? So 90 and 91 make it 180 degrees, means these two interior consecutive angles are supplementary, then these two lines must be parallel. Okay, so this line is parallel to this one here. When it goes parallel here, so it will come out with 90 degree only. So when it comes out, it will not be deviated at all because it's the shortest route. So what do we see in this case? So it is, when we deviate through 90 degree, what happens in it, right? We are able to, okay, if there is an object over here and this is an object, so what do we see? The head will come here, fine, and this is the tail will come there, fine. Is it okay? Have, okay, the two rays of light entering the prism got refracted, right, and became what? Perpendicular to each other. Can you see that? These two are perpendicular to each other. So one ray of light went like this and came like this. Is it not at 90 degree? Fine. So this is called deviation through 90 degree. So this is the angle of incidence, this one, and this is the angle of the refraction or reflection we can call it as. And what is angle between the two? 90 degree. So this is the deviation of light through 90 degree. Is that part clear? So remember, when we have to deviate through 90 degree, we have to use this particular prism in this manner. Now what is the uses of these kind of prism here? We use this prism in periscope, where a total reflecting surface, a reflecting prism is preferred over a plane mirror. Why? Because in prism, entire 100% of the light is reflected back. In plane mirror, some is reflected inside the mirror. There we have done the multiple reflection part of it. So this is why we use. Okay, now comes deviate the light through 180 degrees. So you can see this is 90 degrees, same prism, 90, 45, 45. So we want, right, to deviate it with total. Okay, is the light should go like this and come back. So what is angle of incidence here? And the angle between the angle of incidence and angle of refraction, sorry, angle of reflection. What is angle? One is going, the other is coming down. So is it not? Say this is going and this is coming. So what is angle? 180 degree, returning back. Fine. So it is making an angle of 180 degree here. So how do we do that? We will allow the light to be incident at, say, at 90 degree here. So this is also 90. This is 45. So this will be 45. So if you draw the normal, this angle will be 45. This is also 45 degree. And this is 45. So it is more than the critical angle, 42 degree. It will reflect, total internal reflection because of this. And this also will be 45. It goes the other side. Now remember, this is 45. This is the entire thing is 90. So how much is 45? Similarly, here also it will be 45 because this is 90. 90 plus 45 plus what is 180? So 45 only. So again, you draw the normal. What happens? It has to be 90. So this is 45. It must be 45, more than critical angle. So it will reflect completely 100%. So you can see the one ray going, this is QP. Q will come here, become Q dash after this reflection and refraction both, and P will come here. So is the inverted also. We can see the image is inverted. Earlier it was in facing this side and now it is facing this side here. But again, it has gone through 180 degree deviation here. Is that understood? Next is, now what is the use of this? It is used in binoculars, camera, to invert the image without a loss of intensity of light. I mentioned why we use prism, because of total internal reflection, the no light will get wasted. It is intensity of light will remain the same. In mirror doesn't happen here because it absorbs also, and also refraction, multiple reflection takes place. Now the third part of it was to erect the image, inverted image, without producing deviation. So here it is the deviation. It has erected it, right? It was this way, now it is this side, it erected it, but again it is a deviation of 100 degree, 180 degree, 180 degree. Now here we don't want that deviation to happen, but I want that erect. So if it is inverted, it should become erect. So how do we do that? Again, this is 90 degree, this is 45, 45. So we will not allow the light to pass through or enter through at 90 degrees. So we will have a certain angle, any angle here. So we know that this is a rarer medium, this is the denser medium. So once the light enters from rarer to denser, it will bend towards the normal. It will come here, right? This angle is 45 here. Again, but this angle here, which angle? This angle that we have here should be more than, not this part here, right? It is coming at this angle here. When I say this angle here, this angle should be more than 45 degree. So you allow the ray of light to refract in a manner that this angle is more than 45 degree, more than 45 degree. Okay, sorry, 42 degree. 42 degree is the critical angle, so should be more than 45 degree. If this is more than 45, it will go through total internal reflection, come out and become parallel to it here. Is it clear? Same way the other light will come here, and again in this part, this angle should also be more than 42 degree. So it will go through total internal reflection, and from there again it will refract and become Q. So you see it was inverted, now it has become erect here, but there has not been any deviation. It was going in this way. This is the incident ray and this is the refracted ray also, or refracted both. So has the angle changed? The angle has not changed. There is no deviation at all. So no deviation and erect. So this is the third option that we have in it. Now this action of prism is used in slide projectors. You must have seen the slide projectors. There we use it. Now come the total internal reflection through a prism where each angle is 60 degree, or equilateral prism here. See, you can equilateral prism here, 60, 60, 60. If you have an incident ray coming at 90 degree, it will go straight. We know that the undeviated. Now if this is 90 degree here, what is this? This angle is 30, because 90 plus 60 plus 30 will make 180 degree in the triangle, this triangle here. Sum of all the angles should not be more than 180, less than 180, should be equal to 180. So this is how we get this. This is 90, this is 60, this must be 30. And if this is 30, we know that normal has 90 degree here. This is 90. Out of that, this is 30 degrees. So how much is the remaining angle? 60 degree. So this angle will be 60. So angle of incidence here in this particular prism inside it is more than 42 degrees. So there will go through total internal reflection and 60 degree will come out here. Is it clear? The ray of light would have gone directly like this, but it did not go. So you can see it is deviating out. It is, well, okay, since it is 60 degree here and this is also 60 degree here, you can see this is 60 there, so it will be 30 degree here. This part smaller angle will be 30, 60, so this will be 90 here. So since it is making an 90 degree will come out. Is the part clear? See, this angle is, entire angle is here, from here to here 60, and we know this is the right angle, so normal. So 60 minus 90 minus 60 will give you 30. So this smaller angle here in that particular triangle will be 30. If this is 30, this is 60, it must be 90. This is coming out straight in it. It should have gone straight like this, but it has turned. So what is the angle of deviation here? So remember, this is 30 and the outside is going to be 30 here. So it has deviated by 60 degree here, and we get it out emergent ray. Is it clear? It has gone through deviation by certain angle, and that is deviation through 60 degree. How do we get 60 degree? Once again, see, this angle is 30 and this angle also will be 30 here. So you can say 60, you can calculate that also. Why will it be? Because these two lines are intersecting. This is 30, so this also will be 30. It was already 30, 30 plus 30 is 60 degree. Is it clear? So it has got deviated by 60 degree here. Is that understood? Now next comes here total internal reflection of and refraction of through 30, 60 and 90 here, 30, 90, 60. So what do we see? The ray of light, okay, is entering at 90 degrees. So this angle is 90. So this is 60. How much will this angle be? This will be obviously 30 degree, right? So if this is 30 degree, then total is 90. So 90 minus 30, this will be 60 degrees. So angle of incident here will be more than 42 degree. It will refract because normal there, and it will refract, making the same angle 60 degree will come here. And again, you can see this is total is 90. This is 60 here. Fine. Total is 90 here. This angle is 90, and we know that this angle will be, okay, this is how much? It's going to be 30 degree here. This is 60, right? This is 90. So how much is this angle here? This angle will be 30 degree. So it also will be 30 degree here. Fine. And we can be able to calculate that. But once it makes an angle of 30 degree here, then it will come out, because it is less than critical angle. It will not go through the total internal reflection, and it will come out, right? So you can see ray of light going this way, shifting, and it will make an angle of deviation, okay, less than 60 degree here by a 30, 90 and 60 prism here. So deviation is less than 60 only when we have entering the light in this manner here. Clear? Where? See, if it is entering the light in, entering at 90 degree, 60 degree side here, it will make and come out, okay, and this angle will be less than that 60 degree, right? Now then come, these are the all examples of total internal reflection, right? But there are some examples wherein no total internal reflection happens here. In the same 30, 90 and 60 degree prism, you can see non-occurrence of total internal reflection through 30, 90, 60 prism. See, if the ray of light goes this way and this is 60 degree, this is 30 degree, we know the entire angle is 90, right? And if this entire angle is 90, then how much will this angle be? See, this is 90 degree here, this is 30, will it not be 60? If this is 60, then remaining angle will be what? 30 degree. So we got 30 degree here. So angle of incidence here is 30, which is less than the critical angle. So therefore it will not go through in total internal reflection, it will go out, right? Same in another way, if you allow the light at 90 degree, so this is 90 degree here, you take this triangle, this is 30, how much will this angle be? This angle will be 60 degree, and we know the normal is at 90 degrees, so 90 minus 60, this angle will be 30 degree. So angle of incidence inside the prism is 30 degree, which is less than the critical angle, so it will deviate, not go through total internal reflection here. Is that understood? Next, come here, a ray of light incident normally to the hypotenuse of a prism below the foot of the perpendicular on it from its opposite corner suffers total internal reflection and gets deviated by an angle of 60 degree. You can see what is happening here. This is the hypotenuse here, 90 degree, 60 degree, 30 degree, and you allow the light to come here at 90 degree. So remember, this is also 90, this is 60. How much is this angle? This is 30, and if this is 30 with a normal, we have drawn 90. So 90 minus 30 will be 60. So angle of incidence is 60 degree, which is more than critical angle 42 degree. Fine. So it will go through total internal reflection, making what, 60 again, it will come out. Now this is 90, right? And this is how much? 60. So this will be 30 here. If this is 30, this must be 60. And if this is 60, then if you draw the normal over there, total is 90. 90 minus 60 is how much? This is 60 here. This part is 60. Total is 90. 90 minus 60 will be 30. So you can see the angle is incident is 30, which is less than the critical angle. It will not go through any more total internal reflection. It will come out as a refracted ray. So total internal reflection through 30, 90, 60 prism also in this case can happen, and this is the one here. Then we have got differences, distinction between total internal reflection and reflection through a plane mirror. Okay, remember total internal reflection in a plane mirror, and this is in the glass, a denser medium here. It takes place only when the light passes from denser medium to rarer medium, remember, and that too at an angle of incidence greater than the critical angle. I have mentioned that earlier for that peripedia. It takes place when a light is incident on the plane mirror from any medium or at any angle. Okay, you know that. Entire light is reflected. Here only a part of light is reflected while rest have refracted and absorbed in it, right? Because the surface can absorb. Now here there is no loss of energy because all the entire light has been reflected, right? And here there is a loss of energy because some amount of energy is light energy is absorbed in it, right? And it has gone through the multiple reflection also. The image is much brighter because the entire intensity of the light remains the same. So intensity of the light image is much brighter, and brightness remains unchanged even after the long use of the total reflecting device. Here the image is less bright and the brightness gradually decreases as the silvering of the mirror becomes old and rough here. So you have to, this is important one, you have to remember all of these. And that is all as an introduction that we have about the different kinds of total internal reflection happening in a prism here. Now we will have numericals based on it. So only thing you have to remember is that it should be the total internal reflection will happen only when the critical angle is it is more than the incident ray is incident angle of incident is more than critical angle for